Hey guys, so this video is supposed to introduce you to this idea of a log-log plot, which you guys will be required to use on the Spaghetti Lab. So these are useful when you've collected your data, some x comma y, two variables that you guys have been measuring, and then you think, but aren't really sure, that the equation y equals ax to the n holds. And we're assuming also that both a and n are just constants. They're not variables also. You've already collected the variables x and y, but you need to find out a and n. So the reason why we do this, instead of just measuring it directly, is that sometimes in engineering, it's kind of hard or impossible to measure a and n. So the best way to do it is just by using good old math. So how do you get these two values of a and n from your data, x and y? So what you do first is you take the logarithm of both sides. You can take logs base anything. You can take it like base 2, base e, base 10, 4e to the square root of your mom. Anything. Anything will work, as long as you do the same thing to both sides. So in this case, I like taking the natural log mostly because it saves writing and stuff. So you have ln y is going to be equal to what? Well, it's going to be equal to the natural log of ax to the n. We then use our logarithm rules that you guys probably learned in Algebra 2 and Trig, where ln of ab is equal to ln of a plus ln of b. And also that when you have ln of something raised to another power, you can just bring the power down to give you b ln of n. So if we do things in that order, we can separate this guy up into ln of a plus ln of x to the n, and then move this guy down to give us a ln of a plus n ln of x. And so why do we bother doing this? Well, if we look carefully at this, this is the form y equals mx plus b, right? A is a constant, so ln of a is a constant. So let's call the constant b. Here, we have some sort of constant out front, like a slope, if you will, m. Ln of x is a variable. So if we apply some function f of x, in this case ln of x, to it, it'll just be another variable. So we can just call that a new x. Same thing over here, y. So what happens is that if we plot on our axes, instead of doing y and x, we can do ln of y and ln of x, and it'll give us some line. And this line of best fit, that you can just find out using Excel or some other, like your graphing calculator even. And the slope of this line will be this value, which corresponds to n. So the slope is n, the exponent up here. How can you find a? Well, if you do this in Excel, they'll give you something of the form y equals mx plus b. So we can see here that the constant term b is going to be equal to ln of a. So you just take this value here and take e to this power, and you can get a. In this case, therefore, that a equals e to the b. Where b is this b, and yeah, that b. Right? Cool? So good luck with the rest of your lab, and I'll see you guys later.